Hey friends, so I hope you guys are all doing well. Today we're going to begin lesson 2. Now lesson 1 was rather long because we dealt with both arithmetic sequences and geometric sequences. Lots of schools do that as 2 separate lessons. We chose at our school to do it as 1 lesson and then give you 2 days to do it so that you kind of right away start thinking about the bigger picture of always trying to figure out what type of sequence am I looking at. You should always, the very first thing you should do on a question is always read through the question and ask yourself that. Do I have an arithmetic sequence right now, or do I have a geometric sequence right now? And then as soon as you say yes to arithmetic, you want to be thinking about D. Or as soon as you say yes to geometric, you want to be thinking about R. Okay, so we lumped those together in one big long note so that you'd start having that discussion with yourself right away. Okay, so now in lesson 2, which we will also cover over the span of 2 class days, but it's not as long a note as lesson 1. In lesson 2, we're going to turn our attention to something called series. All a series is an addition of the terms in a sequence. So we can find the sum of the first 5 terms, or we can find the sum of the first 11 terms, or something like that, okay? And really, at the end of the day, it's going to be that we're adding 4 formulas to your formula sheet that you have to be able to recognize and to use in proper context, okay? Just a reminder with formulas, though, all these formulas have their bases somewhere. Like if you sat down and looked at a bunch of summations, the formula comes from the patterning that you would notice when you do all of those summations, okay? We're not gonna create or derive those formulas in this lesson. I'm gonna give them to you and say, hey, this is how it goes. But I don't want you to just think it's random. Okay, everything comes from something in math, and that's just an important thing to keep in mind. Okay, so as the beginning of our warm up here, just to get us going again, we're going to look at a question that we dealt with last lesson, just kind of for purposes of review. So in an arithmetic sequence, t of 5 is 14 and t of 9 is 140. Or 140, sorry. Determine the following. So we want the common difference, the first term, and the value of t of 112. Okay. So first thing we want to do is get that common difference. I know it's arithmetic because I was told so in the question. You'll hopefully recall from our last lesson. To do that, what I'm going to do is I'm going to call this guy t of 1. Now, if I call that guy t of 1, it was t of 5, so I essentially have moved things down by 4. So if I call that guy t of 1, I'm going to need to call this guy t of 15, okay? So that's the first thing I'm going to do. Now, what I'll do is I'll go to my arithmetic formula, which is t of n equals t1 plus bracket n minus 1d. I know t1 is going to be 14. I'm going to plug 140 in for t of n, as long as I plug 15 in at the same time for n. And that's going to give me enough information to figure out what d is. Okay, so I know 15 minus 1 is 14. I'm going to subtract this 14 from both sides and then divide by 14. Okay, so this is me subtracting the 14 from both sides. Now divide by 14 and I get a common difference of 9. Now that I know that 9 is the common difference, I'm not going to use this as t of 1 anymore. I'm going to go back to the reality of it being t of 5. Okay, so I know that d is 9. Now I want the first term. So I'm going to, doesn't matter which one I do, but I'm just going to use this one. And I'm going to plug 5 in for n and 14 in for t of n. And I know that my d is 9. Okay, I'm just going to hide myself for a second to make sure everybody can see all of the words there on the screen. Also gave me a chance to drink some coffee. Okay, so I'm going to plug all that stuff in. And I'm going to solve for t of 1. So 5 minus 1 is 4. 4 times 9 is 36. Subtract 36 from both sides. and I end up with t of 1 is negative 22. Okay, so now I know d and I know t of 1, which means I have the general formula, right? Because the general formula just involves the t of 1 and d, and then it allows us to plug in anything we want for n. So the value of t of 112, I'm just going to plug 112 in for n and solve. So t of 112 will equal negative 22, that's my t1, plus 112, that's my n that I'm looking for, minus 1, and times 9. So 112 minus 1 is 111 times 9, and then minus 22 is 977. So t of 112 is 977. Okay, so just a quick kind of review of items that we discussed yesterday or in our last lesson, just to get you thinking through what's going to happen today. Okay, all right. Find the sum of all the integers from 1 to 100. I would love it if you paused me at this point and just played with that for a sec. See what you can come up with. Okay. Okay, hopefully you paused me for a quick sec at least. I'm just going to write down the pattern for a second. Okay, so I've got 1, 2, 3, 4, 5, and then a bunch of stuff in the middle, 95, 96, 97, 98, 99, 100. Okay, now, when I do this sort of thing, I'm always looking to see if I can pair up some friendly things. Okay, so I'm thinking, okay, hey, look at this. 1 and 99 is 100. 2 and 98 is 100. 3 and 97 is 100. 4 and 96 is 100. And 5, guess what? 5 and 95 is 100. Okay, so I can see all these friendly pairs, and I can imagine that I'm going to be able to pair that up. Actually, all the way to where? Where would I be able to pair that up until? Can you think of that? My last pair would end up being 49 and 51. Okay, so here's what I want you to think of there. If I started to pair 1 and 2 and 3 and 4 all the way up to 49, that's 49 100ths. Do you agree? 49 100ths. Okay, that's great. But then a couple things that I haven't included in that yet. I never included this 100 here. And I never actually included the 50 that would have been right in the middle, right? I said the last pair that I had was 49 and 51. Now, you could look at this in two different ways, okay? I looked at this as 49 100ths, and then I'm going to add in my 50 and my 100. You could have said, hey, why don't I call it 50 100ths and have my first pair be like 0 with 100 essentially, okay? I didn't have 0, and that's why I didn't want to do that. But you could, right? You could say I have 50 sets of 100, and then the only thing I'm missing is 50. Either way, you're going to get to 5,050, okay? Now, I gave you a friendly little guy here that you could add together easily, okay? Where I want to take you is with this formula, okay? This is what we call a summation formula. That's what the S is there for. So it's the sum of the n terms, okay? However many terms I want would be n over 2 bracket t1 plus tn, okay? So if I want all the integers from 1 to 100, how many terms am I dealing with there? I'm dealing with 100 terms, right? And I know that my first term is 1 and my last term is 100. Sorry, I just want to back that up. I thought I was going to write something down there, but I will write it for you right now. So I could say S of 100 equals, whoa, that was a bad 0, 50, right? That's 100 over 2 plus 1, or times, sorry, 101. What's 50 times 101? 50, 50. Okay, so it works with this particular guy that we were solving by hand. Okay. All right, so a series is the sum of a sequence. Therefore, an arithmetic series is the sum of an arithmetic sequence. We use S of n to denote the sum of the first n terms. So S of n would be like t of 1 plus t of 2 plus t3, all the way to tn. Okay, to put in numbers, S of 50 would be T1, T2, T3, all the way up to T of 50. Okay. So there are two different formula that we use for arithmetic series. And the difference between them is whether we know what that final term is, which we're denoting as T of n, or whether we don't, okay? So for this guy here, S of n is n over 2 times T1 plus Tn. So that's your first term plus your last term, times that by the number of terms and divide by 2. That's essentially what that says, okay? And if you recall in my kind of startup example here where we added the numbers from 1 to 100, I actually showed you that formula and showed you that that worked to get that 5050. That was the sum of the numbers from 1 to 100, okay? The other guy, S of n equals n over 2 times 2 T1 plus n minus 1 d. This one is used when we don't know the final term, okay? So for one like this, we have established the pattern and it might say find the sum of the first 99 terms or something like that, but we actually don't know what the 99th term is. And so we can use this second formula instead to get there, okay? So just a reminder of each thing, S of n is the sum of the first n terms, where n is the number of terms in the sequence. T1 would be the value of that first term, okay? Tn is the value of the last term, and then d is the common difference, okay? So those are the two formula for arithmetic series, okay? Now we'll turn our attention very quickly to a geometric series. And again, there's going to be two different formulas, and all these formulas are given to you on your formula sheet. They're not things that you have to commit to memory, but you have to know when to use them and how to use them properly, okay? So a geometric series is the sum of a geometric sequence. Our formula for the geometric series is, and again, we have two of them. The first one here is if we don't know T of n, so it's T of 1 times R to the n minus 1 all over R minus 1. Or if we do know the last term, we can go S of n equals R times Tn minus T1 over R minus 1, okay? So as we go through these questions, you end up asking yourself a series of questions as you're trying to figure this out. So the first thing you're always going to ask yourself is this arithmetic or geometric? Okay. And as soon as you say it's arithmetic, that splits your formulas down in half. If you said it was geometric, it splits it to the other half, right? Then you're going to ask yourself, am I looking for a general term or am I looking for a series? Am I trying to find one term or something about one term, or am I trying to add up a bunch of terms? If I'm trying to add up a bunch of terms, then you're looking for an S of n formula, not a Tn formula, okay? And if you find yourself looking at the Sn formulas, the final question you have to ask yourself is, okay, do I know that last term? Do I know Tn? If you do, use the formula that involves Tn. If you don't, use the other formula. Okay, and that's what we'll practice as we go through and look at all these. So just to reiterate the definitions for these guys, Sn is the sum of the first n terms. T1 is the value of the first term. Tn is the value of the last term. And R is the common ratio for this guy. Okay. And then finally, n is the number of terms in the sequence. Okay, good. So let's try some examples. Given the series 3 plus 7 plus 11 plus 15 plus ... determine S of 50. Now, first thing you want to ask yourself, is this arithmetic or geometric? Well, I'm going from 3 to 7, 7 to 11, 11 to 15. Hey, I'm adding 4 each time. So this is an arithmetic series where the common difference is 4. Next thing you want to ask yourself is, do I know the last term? And the answer is no, I don't actually know off the top of my head what T of 50 is. Now, I could solve for T of 50, that's okay to do, but the formula allows me to not have to make that separate question, okay? So it's arithmetic, D is 4, and T of n is not known. Okay, so that takes me to this formula. S of n is n over 2 times 2 t1s plus n minus 1 times d. Okay, so again, I'm just going to take stock of what I know. I know 50 is my n, so I'm going to plug that in for n here, and I'm going to plug it in for n there. I know my first term is 3, so I'll plug that in right there. And I know my common difference is 4, so I'm going to plug that in right there. Okay, so I'll plug all those things in and then just do the math. So I end up with S50 is 50 over 2, 2 times 3 plus 50 minus 1 times 4. Now 50 minus 1 is 49. I can do 49 times 4, add 6 to it, and then multiply it by 25 because that's 50 over 2 is 25. And I should get S of 50 equals 5,050, okay? S of 50. So if I took those first 50 terms and I added them all together, the sum of that would be 5,050. Okay, given the series -3 plus 6 plus -12 plus ... determine the sum of the first 7 terms. Okay, again, we got to look at this and say, is it arithmetic or geometric? Well, I'm going from -3 to 6 and then 6 to -12. I'm multiplying by -2 every time. So if I'm multiplying by -2 every time, I know it's geometric. I know my R value is -2, and I don't know T of n. Okay, and I'm asked for S of 7. I'm looking for the sum of the first 7 terms. So it's geometric, R is -2, and T of n is not known. So I head to the proper formula. I'm looking for a summation formula, an SN formula that involves geometric and where T of n is not known. Well, that is this one here, T of 1 times R to the n minus 1 all over R minus 1. So I know that T of 1 is -3. I know that R is -2, so I'm going to put that in there, and I'm going to put it into that R there. And then for n, I know it's the first 7 terms, so I'll plug that in for n here and for n here. Okay. So here I go doing all of that substitution. So I get -3 times -2 to the 7 minus 1 all over -2 minus 1. Now, just a little note about this guy here. And remembering that calculators are only as smart as the person pushing the button, you got to be really, really careful with this, okay? If you have a negative R value, you need to remember to put that negative R value in its own set of brackets before you apply the exponent, okay? Wouldn't matter for this one because it's to an odd exponent, and so you're going to get a negative number anyway, but it would totally matter if that was to the 6, right? Because if you are not including the negative, you're going to get a negative number, but if you do include the negative, you actually end up with a positive number when it's to an even exponent. So it actually makes a big difference. So you got to be careful that you're treating those negative numbers properly, okay? All right, so when I do that, you should end up with S7 is -129, okay? So the sum of the first 7 terms is -129. It is okay to have a sum that's negative. A sum that's negative just refers to there'd be more negative terms there, or maybe even not more negative terms, because really half your terms are positive and half your terms are negative if you're looking at this. But the magnitude of the negatives is greater than the magnitude of the positives. That's why my overall answer ended up being negative, okay? And that's okay. What can't be negative is your n value. If you ever solved and got a negative n value, there's some problems there, right? Because n has to be a member of the natural family. Okay. Okay, given the series 2004 plus 1962 plus 1920 plus 1878 plus ... determine S of 100. So again, same sort of questions that you're going to ask yourself. You need to say, hey, is this arithmetic or geometric? Well, 2004 to 1962 to 1920, I feel like that's arithmetic. Now, if I wanted to check, I can grab my nice calculator and I can go 1962 minus 2004 and I get negative 42. Well, if this is truly arithmetic, I can go 1920, subtract 1962, and I should get the same answer. And I do. They both end up being negative 42. So I know I've done good. Okay. So it's arithmetic. I know my D value is negative 42 and my T of n is not known. Okay, so that takes me to this formula and I'm going to plug in everything I know. So I know that T of 1 is 2004, D is negative 42, and I know that n is 100. So I'll plug in 100 here and over here. Okay, all right, so let's do that. And I end up looking like this. 100 divided by 2 is 50. And then I'm going to have 2 times 2004 plus 99 times negative 42. Okay, put all that in your calculator. Pause me and make sure you're doing it right before you check my answer. And you should end up with S of 100 is negative 7,500. So the sum of the first 100 terms of this sequence or of this series is negative 7,500. Okay? Okay, so next example, determine the sum of the series, and we've got 1 over 64 plus 1 over 16 plus 1 over 4 plus a bunch of stuff, and then plus 1,024. So the first thing I want you to see here is I have an example where T of n is known. I know where this guy stops, okay? I have to figure out whether it's arithmetic or geometric. Well, when I see 64 and I see 16 and I see 4, I can tell that I'm dividing by 4 every time there. Okay. Now, dividing by 4 on the bottom, overall, I have to decide what I'm doing. But I'm looking at these bottom numbers right now and saying, oh, I know that this has to be some sort of geometric guy. Okay. Now, I'm not dividing by 4. Okay, that was just the pattern that I first saw. I need to look at this as a fraction. It's 1 over 64 to 1 over 16 to 1 over 4. I'm actually multiplying by 4 every time. Now, that may frustrate you and you may say, how was I supposed to know that? Well, it's okay. Look at it this way. Take 1 over 16 and divide by 1 over 64 and see what you get. Okay, take 1 over 4 and divide by 1 over 16. Remember, that's how we get the common ratio. We take any term and we divide by the term that comes before it, and that will give us the common ratio. Okay, so I know it's geometric. I know R is 4. This time I actually know that T of n is 1,024, but the glitch in this one is I don't know how many terms I have. Okay, so the first thing I'm going to do is I'm going to head to my general term geometric sequence formula. And I'm going to try and figure out how many terms I have. Okay, so I've got T of n equals T of 1 times R to the n minus 1. I know I can put in 1 over 64 for T of 1. I know I can put 1,024 in for T of n. I'm just going to hide my head here in case some of you at home didn't see the 1,024. Okay, I know R is 4, so I can plug that in here. And now I'm going to solve for n. Okay, so I have 1,024 equals 1 over 64 times 4 to the n minus 1. I want to get rid of that 1 over 64, so I'm going to multiply both sides by 64. Remember, I can't multiply here because the 4 has an exponent, and I have to deal with that exponent before I can deal with that multiplication. So instead of that, I'm going to follow the mathematical rules of life and multiply both sides by 64 instead. Okay, that's going to give me 65,536 equals 4 to the n minus 1. Now, we had an example like this in the last lesson where we were trying to figure this out. I'm going to grab my calculator and I'm going to go 4 to the something, 4 to the something, 4 to the something until I figure out what gives me 65,536. Okay, that was 4 to the 8. Wouldn't have taken you too long, I'm hoping to find. But if 4 to the 8 now equals 4 to the n minus 1, I know that n has to be 9. There has to be 9 terms in order for all of this to work. Okay, so now that I know that n is 9, I can go back and actually answer the question I was asked, which was find the sum of this series. So now I know it's the sum of 9 terms. So I'll be looking for S of 9, but I know T1 and I know Tn. Okay, so I'm going to switch the formula that I use to the one that uses Tn. So this is going to be R. I know R to be 4. Times Tn, I know that to be 1024, minus T1, I know that to be 1 over 64. Okay, and then on the bottom, I have 4 minus 1. Okay, so I've just plugged in everything. I'm now going to throw that in my calculator and get a solution. You should be pausing me, of course, and checking that yourself first. Okay, and your final answer there should be 87,381 all over 64. Okay, leave it an exact value unless you were told otherwise. Okay, awesome, guys. All right, determine the sum of 13 plus 15 plus 17 plus a bunch of stuff plus 49. Again, another example where I'm told T of n. Fantastic. First thing I need to ask myself is, do I have this as an arithmetic or geometric? 13, 15, 17, I'm adding 2 every time, so I know it's going to be arithmetic. Again, I know that D will be 2, but I don't know n, okay? So I'm gonna have to do a little digging and solve for n. So I know it's arithmetic, I know D is 2, I know T of n is 49, n is not known. So I'm gonna go back to my general form, T of n equals T1 plus n minus 1 times D. I'm gonna plug in 13 for T1, I'm gonna plug in 2 for D, I'm going to plug in 49 for Tn, so I can solve for n. Okay. So that leaves me with 49 equals 13 plus n minus 1 times 2. I'll distribute that 2, so that's 2n minus 2. 13 minus 2 will give me 11. Subtract 11 from both sides, and I get 38 equals 2n. So then that's n is 19. There are 19 terms in this sequence. Okay, so now that I know there's 19 terms, I know my first term and I know my last term, I'm going to use the summation formula for an arithmetic series that uses T of n. Okay, and that's this guy here. So I've got 19 over 2 times 13 plus 49. Okay, throw that in my calculator and I end up with a summation of 589. 589. Okay. Awesome. All right. Old man Ostrander is reminiscing about his days as a stock boy when he earned $1 a day for stacking loaves of the newly invented sliced bread. The old man would stack the loaves in the shape of a pyramid with 20 loaves on the bottom layer, 1 loaf less on each successive layer until there was only 1 loaf at the top. He believes that his display has 200 loaves of bread in it. Is he correct? Okay, so I need to take this information and start trying to build a system here. I know that I'm going to go 20, 19, 18, 17, right? I'm just going to start at the bottom row and kind of build my way up. So I can see that that's an arithmetic sequence where my D value would be -1, okay? My D value would be -1. So I have an arithmetic sequence. My D value is -1, and my T of n, my last term, is 1, because it said I'm going to keep doing that until there's 1 on the top. Okay, n is not known. Now, you could say you could figure out n logically, but I'm going to show you how to solve for n. Okay, we're going to go back to that general formula for arithmetic sequence. We're going to plug in T1, we're going to plug in D, we're going to plug T of n in, and we're going to figure out what n is. And I end up with n is 20. Okay, now again, some of you may say logically, well, if you started with 20 and you're subtracting each one, shouldn't you have 20 rows? Yes, but I want to show you how to do it and support the algebra, okay? Or have the algebra support your work. Okay, so now I'm going to go back to the summation formula. I know that I'm looking for S of 20, so that'll be 20 over 2 And then t of 1 is 20 and t of n is 1. Okay, so that becomes 10 times 21. So there's actually 210 loaves of bread in that little pyramid, which I would say isn't that little of a pyramid, but there are 210 loaves of bread. So Ostrander was not correct here. There was actually 210 loaves of bread. Okay, and again, for you folks at home who are like, you didn't give me enough time to look at the question, there is the question. I will hide myself for a second so that you can see the full question. Okay, all right, fantastic. Ostrander actually has 210 loaves in his display. All right. A ball is dropped from a height of 15 meters and bounces to 60% of its previous height. How far has the ball traveled vertically when it hits the ground for the 4th time? Round to the nearest 10th. Okay, so there's a lot going on in this question. We're going to try and unpack it. This is a very famous sort of test question that we like to ask, okay? First, visually, if I drop a ball, okay, what can I have on my messy desk here? I'll just take a mark for a second. If I drop a ball, it's going to come down to the bottom and then it's going to come up, but it's not going to come up as far as where I released it, right? It's only going to come up part way. So what we're saying is it'll always come up 60% of what it dropped. Okay, so the first thing you probably want to do here is just draw yourself a little picture. Before I draw, I'm just going to hide my face for 1 second so that those at home can read the question. All right, and now we'll get going. So I'm going to draw myself a little picture. T of 1 is going to be the distance dropped to the first bounce, okay? So I've got something that looks like this. I'm dropping the ball, and then T of 1, so this distance right here that you can see my mouse going over, that would be T1, and then this would be T2 here, and then this would be T3, and then this would be T4, okay? I want to know the total distance the ball has traveled vertically when it hits the ground for the 4th time, okay? Well, I know that this is geometric. I know I'm rising by 60% each time. Okay, so I know that T2 has to be 60% of T1, right? So I'm going to look at a summation formula where I've got T of n is not known, okay? So I know T of 1, though. T of 1 will be 15. I know R is 0.6, okay? And I know n is 4 because I've got myself to the 4th bounce, okay? So I plug all of that in, and I get, when I type all this in my calculator, I'm going to get 32.64. Okay. Now, that's not the answer to this question, but it's a good start to the answer to this question. And I want you to pay really close attention to the visual I want to show you here. What you just did was you got all of the downward drops. Okay. So you essentially got this yellow highlighted pieces. Okay. The question actually asked, how far has the ball traveled vertically? So we're missing the going up pieces, okay? So logically, one might say, okay, well, let's just take that answer and double it, okay? Because if I went down, I must have gone up, right? Okay, so here's the problem with that. If I double it, watch the screen very closely, I end up doing this. I double every yellow line. And what I need you to see here is this green portion right here that I'm circling with my mouse. That's actually not part of the question because I started at 15 meters high, okay? So yes, I'm good to double it, but then what I'm gonna need to do is subtract that 15 that I don't need, okay? So that actually ends up being the total vertical distance will be doubled what I got minus 15. Okay, and that's going to end up being 50.3 meters. Okay, 50.3 meters. All right, that's a gooder. Okay, so the last example I want to walk you through looks like this. A geometric series is defined by S of n equals 5 times 3 to the n minus 1. Determine the first 4 terms of the geometric series. Now, I'm asking you for the first 4 terms, but I didn't give you a general term formula. I gave you a summation formula. So this is kind of cool because I want to walk you through how you can use the summation formula to actually figure out terms. let's start finding the sum of the first term. That'd be s of 1. Okay, well, s of 1 is 5 times 3 to the 1 minus 1. 3 to the 1 is 3. 3 minus 1 is 2. 2 times 5 is 10. So the sum of the first term is 10. Now think about what I just said. The sum of the first term is 10. Doesn't that mean the first term has to be 10? Right? Because there's only one term there. Okay, let's take a look at s of 2. Well, s of 2 is 5 times 3 squared minus 1. 3 squared is 9. 9 minus 1 is 8. 8 times 5 is 40. Okay. The sum of the first two terms is 40. Well, let's just keep going for a sec. Let's get the sum of the first 3 terms and the sum of the first 4 terms. You're going to pause me. You're going to do that right quick. It's all going to be lovely. So you should have gotten the sum of the first 3 terms is 130, and the sum of the first 4 terms is 400. Now, how do we use that to figure out what the actual terms are? Well, I've already talked about term 1. We know that term 1 would have been the sum of the first term, which is 10. Now, T2, well, the sum of the first 2 terms is 40, and I already know that the sum of the first term is 10. Doesn't that mean the second term has to be 30? Do you follow my logic there? So what we can say is the second term has to be the sum of the first 2 terms minus the sum of the first term. Okay, and that's where we get the 30. So take a look. That still works here. The sum of the first 3 terms is 130, but the sum of the first 2 terms is 40. So the difference between those has to be what the third term is. So the third term is the sum of the first 3 terms minus the sum of the first 2 terms, which would be 90. And then the sum of the first 4 terms is 400, but the sum of the first 3 terms is 130. Well, then term 4 has to be however I go from 130 to 400, which would be 270. And then take a look at this. I can see a pattern. I go from 10 to 30, 30 to 90, 90 to 270. I'm actually multiplying by 3 every time. Okay? Okay, so the first 4 terms in the series are 10 plus 30 plus 90 plus 270. Okay? All right. Fantastic. Now, in your book, for those of you who do have the book, you will have this lovely little flow chart, which just kind of helps you walk through what we're doing, okay? And I've kind of been walking through this flow chart just in the questions I ask you. You want to first say, is it arithmetic or geometric? Then you want to ask yourself, is it a sequence or is it a series? And do you know the, if it's a series, do you know the last term or not, okay? And that kind of will always hone down into the one formula that you need to use. Okay, so use this to help you with your homework. You won't have this flow chart on a test or an exam or anything like that, but use it just to help you familiarize yourself with kind of the thinking process of how to get this done. Okay, all right, so those of you who are with me at school, this is your homework. And to all of you, if you have any questions, please connect with me. You know where to find me. Don't ever feel you're alone doing this stuff. That's what I'm here for. Okay, you guys got this. I will see you at the next lesson where we talk about adding the sum to infinity. It'll be super, super fun. All right, until then, take care, guys.